Okay, so getting into this next video, we're going to take a look at interfaces. And in order to talk a little bit about interfaces, I want to look at a totally new project. So we're pretty much done with our shape project. And I'm going to look at this farm management system that I've got right here. And I've got a set of Java files in here that I want to go through briefly. So the first one is going to be this farm, which is going to hold the main method, which has all of our different classes, these other additional classes inside of it. The way this is going to work is for each one of these classes, we've got our chicken, cow, horse, pig, and sheep. We've created an array list to hold objects of each of those classes so we can keep track of how many of each of those animals are on this farm. So as the name would imply, we're going to be managing our livestock on this farm. Okay, so the way that we're going to do this, we've got an import for the array list, so we can go ahead and use those. We've also got an import for the scanner class, since we're going to let the user input the amount of each animal. The way that they'll be doing that is by essentially just adding an animal to the farm. Each time they add an animal, we'll go ahead and make an object for that animal's class and put that into the appropriate array list. So stepping through this, we've got our 5 array lists for each one of the different animals. We've then got these declarations for each one of the reference variables that we'll be using for each of our 5 animals. We've got a string for the user's input, and we've got a scanner object for keyboard as well, so we'll be reading from our standard input. And then we'll go ahead and have a condition that allows the user to exit the program by typing in the word end. So we've got this little condition here that we're going to be constantly checking for. Every time that they enter something other than that, then we can just go ahead and go through the body of this this while loop that we have here. And what we're going to go ahead and do, so you got please enter an animal to add to the farm. We'll then go ahead and read in the next line. And I've set up a switch. There are 2 different ways that they could input the name of a particular animal from one of these classes. They'll either do it with a capital letter or not. So those are the 2 different cases that I'm going to be checking for. For each one of these, whenever they input something that matches one of these case names, we'll go ahead and just create a new object that we can assign to our reference variable, and then we'll just go ahead and add in, using the reference variable, we'll add that to the array list. Alternatively, if you want, you could also remove these 5 and just specify this new object to just put right into here. Okay, so there's a couple of different ways that we could approach this. So we've got it for chicken, 2 cases for that, cow, 2 cases there, horse, pig, sheep, 2 cases for each of those. And then if they type the word in, we're just going to go ahead and break without doing anything. That way then we can just kind of type in right here, we do nothing in our switch, and then we exit the while loop based on this condition right here. Otherwise, if they enter anything that doesn't match any of these cases, then we'll just go ahead and give them a quick reminder of what it is that we're expecting. And then once we've done all that, then we're going to go ahead and print out the contents of the farm. So for each one of these array lists, I've made an enhanced for loop. So I've got 5 of these for each one of those 5 array lists. And then inside of here, we're just going to go ahead and print out each one. So we're using the customized 2-string method for each one to just print out the objects. And we'll see in a moment what the content of those strings is going to be. And then we've also got a unique method for each of these 5 that is related to some kind of sound that they would make. So if we come over to each one of these, there's a couple of different things that we're keeping track of. So we've got a name that we associate with each one of them. Basically what I've done for the name is just kept track of the number for it. So for example, the first chicken that we add to our farm, its name will be chicken 1. The second one that we add will be chicken 2, and so forth and so on. We also keep track of the number of chickens, so that's how we're able to use that naming convention, is by just keeping track of how many chickens we've added with a static variable. We then also have our cluck and 2-string methods. So cluck, for the chicken, what that's going to do is just print out the word cluck. So it's basically just a way to describe the noise that that particular animal will make. And then for the 2-string method, all we're going to do is just print out this is, and then the name with it. So in the case of the first object, or the first chicken object that we add, it'll just say this is chicken 1. For the second one, it would say this is chicken 2, and then so forth and so on. And if we go through each one of these, we can see a similar setup for this. So we've got our name, our static int for the number, our constructor, some additional method for the sound it makes, and then a toString method. And so we can briefly just kind of glance through the code for each of these and just kind of show you that each one of these looks pretty much identical. Okay. And so now that we've seen all that, what I'm going to go ahead and do is compile all this. So in order to do this, since I didn't set this up to use packages, so we don't have like a package statement at the very top of this program, what I'm going to go ahead and do is just navigate into this farm management folder that I've placed into my Java projects. So I'll come over here. I'm going to do a cd into farm management. And inside of here, what I'm going to go ahead and do is just use a sort of shortcut for compiling all of these Java files. So I'm going to use the Java command. And then right here, instead of typing out the name for each one of the files and compiling them all individually, I'm going to use the star. So similar to if you've ever seen this with your import statements, where we can use the star as a sort of wildcard to just import all of the classes in a single package. We can also do that with some of the different commands in our terminal. In this particular case, I'm going to use the wildcard to specify that basically it's just going to represent the name of any file. And then I'm also going to add .java. And so what this is going to do is say any file, so a file with any name, but also that has the ending extension .java, we're going to go ahead and put that through this Java command. So basically, if you try to read this in just kind of plain English, you're saying we want to compile every Java file in this location. So I'll go ahead and do that. So I've gone ahead and compiled all of those files. Now I can go ahead and run it, and we're going to be running the farm class since that has the main method inside of it. So go ahead and run that, and now it's going to wait for us to enter an animal to add to the farm. So let's go ahead and just add one of each. So we're going to have a chicken, a cow, a horse, a pig, and a sheep. Okay. So now that we've added all those, then I'm going to go ahead and type in the word end. That's going to terminate this while loop and then print out the remaining couple of statements that we have right here at the end. Okay. And so then we can see this is chicken 1. We then print out the sound that it makes. This is cow 1, this is horse 1, this is pig 1, and this is sheep 1. So this is kind of just showing the overall setup for everything in this program. So there are a couple of things to take note of about the way that I've set this up. To start with, we can see that we've created a different array list as well as a different enhanced for loop for those array lists that corresponds to each of the different classes. Assuming that we want to take this approach, we've also had to create a different object or a reference variable that will hold objects of each of those different classes. And also, whenever we create the methods for them, we also take note of the fact that we gave them different names. So based on the class that we're working with, whether that's the chicken, cow, horse, pig, or sheep, the methods that exist inside of them aren't necessarily consistent between them. So they could have different methods inside of them, even though technically they're all farm animals. And so ideally what we'd rather have is probably something that's a bit more uniform, where they essentially all have nearly identical behaviors. They're close, but I think we can do a little bit better. And so the way that I want to go ahead go about fixing that is by introducing a totally different approach, or at least a fairly different approach. So we're going to go ahead and close all the files related to our farm management. Go ahead and minimize that. And we'll take a look at this polymorphic farm that I got over here. So we'll open up the farm class. So looking inside the farm class, we've still got our array list and scanner. We come down to right here, and we've got our initial setup with our array list. But now we're going to be doing an array list of just one class, which is this animal class. We've also gone ahead and created just a single object, again, just for the animal. And then when we come down here, we'll see that our while loop and our switch will stay the same, since we still do pretty much the same behavior. One thing that does change is what we're going to do with each of these cases. So now what we're going to go ahead and do is just assign a different kind of object to animal. And what's really convenient about this is we can do this polymorphically because of the fact that when we look at animal, or at least when we look at each one of these other files in a moment, we'll see that they all inherit from the animal. And so right down here, I have one additional check that I've included right here to make sure that the thing that we've provided is something that matches up. So we want to make sure that animal is an instance of the animal class. And if that's the case, then we can go ahead and add it. We'll also do our check to see if the user put in the word end, if they want to go ahead and terminate here. And based on that, then we can determine if we want to go ahead and add something to the animal array list. And then right here at the very end, instead of doing 5 separate enhanced for loops, since I only created a single one that holds all of the different animals, now I'm just going to go ahead and print that out. You'll also notice that I've changed the method that I'm going to specify, and so now I just have a single method called make noise. And so then if we open up animal, this is the part where things become a little bit different from what we've seen so far. So you open up animal, and you might immediately notice 2 things. One, the code is extremely short because of the fact that we have just 2 abstract methods with no implementation. The second thing is the fact that we're not actually dealing with a class anymore. So instead what we're dealing with is actually the animal interface. So this is one of the first instances now where we've seen some code in Java that does not represent a class. Instead, this represents an interface. And the distinction between an interface and a class is that an interface is effectively an abstract class taken to its extreme, which is to say that it's an abstract, essentially it's like an abstract class, except that now every single method is abstract, okay? And so when we do this, if we look at any of these other classes, so we'll start with the chicken, now what we can go ahead and do, instead of using the extends keyword, because we're not dealing with a class for animal anymore, we're dealing with an interface, now we're going to use what is known as the implements keyword. So essentially what this means is that now chicken is going to implement all of the abstract methods that are in the animal interface. So we're going to say implements animal. And so then we come down here, if we look at our animal interface, we see we got 2 methods that we have to implement, which are make noise and toString. And so if we look in any one of these different other files that are going to implement animal, they all must have make noise and toString. So we see in chicken, we see this in cow, we can see this in horse, we can see this in pig, and we can see this in sheep. So the really convenient thing about creating an interface and doing this with it, there are 2 really huge benefits that come with this. The first, as we can see in the farm class, is that now we can actually just rely on polymorphism to significantly reduce the number of lines of code that we have to write. So instead of having to make 5 different array lists, one for each one of the animals, now we can just make a single array list of this animal interface, and through polymorphism, we can just go ahead and add objects of any of these subclasses that implement that interface. The second thing that's really useful about interfaces that we can see looking through all of these other files is that I've specified 2 methods by making them abstract methods inside of my interface, and by doing that, I've set it up in such a way that now anytime I create anything that implements the animal interface, there is a clear distinction that it must have these 2 methods inside of it. So if I were to remove one of these methods, say like I just comment this out, and then let's come over here, go ahead and clear this, go ahead and navigate back up to my Java projects, and then we'll navigate into the polymorphic farm. And so inside of here, I'm going to do the same thing. I'm going to try to compile this like so. And when I do this, it's going to give me this error warning. It's going to say chicken is not abstract and does not override the abstract method make noise in animal. So now, whenever I create something that implements the animal interface, if I don't include the methods that come with that interface, I'm going to get this error warning. So this serves as a sort of like a check that warns me that I've forgotten to implement something that is essential for this program. So there's a higher degree of security by designing it this way. Say, for example, if you're trying to work on an application that deals with, say, like a testing suite or testing software for like a manufacturing plant, for example, by making sure that you create an interface at the very beginning and then you build a bunch of classes that implement that interface, you can help to guarantee that each one of those classes that you build must implement those methods so that you don't miss anything along the way. What this is known as is that we can essentially describe our interface as being sort of like a contract. It's a sort of binding resolution that says that, by specifying these particular methods inside of it, anytime I create a class that will implement it, I must make sure that each one of those methods, each one of those classes implements those methods from that interface. Okay. So we'll go ahead and uncomment all of those lines. We'll save that. And then one other thing I want to make a mention of as far as the syntax for this goes, you might also notice that even though I created these two abstract methods, I didn't use the abstract keyword to indicate that they're abstract methods. The reason that I didn't do that is because once you put these inside of an interface, you don't have to include the abstract keyword anymore. It's pretty much a given, because of the way that an interface works, that you must have abstract methods inside of it. Okay. So now that we've seen that, we can go ahead and compile this. So we'll go ahead and try compiling this again now, since I've uncommented that line. So compile it without any errors. We can then go ahead and run our farm. And now we see that we still have the exact same behavior as before. We've just managed to reduce the number of lines of code for it. And we've also managed to make sure that it is more secure than it was before by establishing that contract between the interface and the classes that implement it. So if we go ahead and enter our animals, we can do essentially the same ones. We can have our chicken, our cow, our horse, pig, and sheep. And then we'll go ahead and end it. And then we can still see each one of those animals being printed out to the console. Okay. One additional thing to make a mention of about interfaces, if we wanted to, we could also incorporate methods that are implemented. The reason that you might do this is because of the fact that you might be in a situation where you've already created several methods for your interface, and you've created, in this case, 5 classes that need to implement all of the methods of this interface. But maybe you want to introduce another method that all of these classes are going to use, and the way that they're going to use it is exactly the same. So what you can go ahead and do is actually make what are known as default methods. So you can do public, default, and then just specify the rest of this. Let's say, what can we use? Maybe just a simple print statement for this one. So we'll just say public default void print message. I'll just use something really simple to be able to demonstrate how this works. So then we can just go ahead and have our print statement right here. We'll just print out something like this is a default method. Okay. And so whenever we do this, this helps to simplify the process of having to go into every one of these different classes and implement that method. Instead, we can just go ahead and do it right here. So this is really more of a fail-safe whenever we encounter a situation where maybe there was a particular method that we had neglected to include, or it could also be the situation where we just knew that we were going to include this method, but we also knew that the implementation for it would be exactly the same across all of our methods. So we want to go ahead and make an interface, but on very rare occasions, we want to go ahead and sort of invert the responsibilities of that interface. So we can come over to our farm and then say maybe right down here, in addition to the make noise, we could also go ahead and grab one of our output animals and just call this print message method on it. Okay. And if we recall from dynamic binding, because of the fact that the interface is what's going to be holding this, but none of the classes that implement it hold that method, even though we're doing polymorphism, since the item right here, or this output animal that we have right here, is going to be essentially the reference variable to the object, the type of the reference variable, that indicates where we're going to initially be looking for this method. So the print message is essentially, it's exactly where it's supposed to be in order for this to function properly. So if you come over here, we'll go ahead and clear this. We can recompile everything. And then we can go ahead and run our farm. And for this one, let's go ahead and just add one item. We'll just add a cow to this and then end it. And then we can also see our print statement from our default method. Okay. Okay, so this is going to cover everything for interfaces. Going into the last 2 videos for this set, going through inheritance, we're going to be taking a look at some things that are not directly related to inheritance, but are instead additional ways that we can go about implementing some of our different classes, and those are going to include things like anonymous inner classes and lambda expressions.